Hello everyone. So today we're going to be solving USACO's 2016 December contest runs problem 3, the cow signal. So the problem statement reads as follows. Bessie and her cow friends are playing as their favorite cow superheroes. Of course, everyone knows that any self-respecting superhero needs a signal to call them to action. Bessie has drawn a special signal on a sheet of M by N paper, with M and N being between 1 and 10, very small constraints. However, this is too small, much too small. Bessie wants to amplify the signal so it is exactly k times bigger, k 1 to 10, in each direction. The signal will only consist of dots and crosses. So the files here, so we're given the lines of input, we're given the lines of input M, N, and K, and we have the next M by N lines containing the given signal or symbol they've drawn on the paper. So we need to make this k times bigger, and on the output it says k by m and k by n. So it needs to be bigger by km times. So if the length is 4 and k is 2, it should be 8, which as you can see it's here. So we have the sample inputs here. So we have a 5 by 4. So that's 5 by 4, and we need it to be 2 times bigger. So some quick observations. You can see that there's 3 x's here, and there's 6. So it's increased by 2, which is k. And same with the dots, there's now 2 dots. So immediately, for like each row, we can tell that for every x, there should be, or for every single like character on each row. So if we just break it down to like this, and k is equal to 3, then each character should be, so there should be 3 of each character, so there'll be 9 x's, so, there'll be 9. Okay, so now we see how to do it row-wise. However, if you see it's K, N, and KM, so N and M, I'm sorry, I forgot which one's which, but it's horizontal and vertical direction. So we should also increase it by the vertical direction. So we can see over here, this is like doubled. So this is multiplied by 2. So once again, if we have this and K is 3, there should also, for each character, there should be another 3 rows. So the way I'm going to solve this problem is I'm going to create the final row, and then I'm going to add that k amount of times to increase it, kn and km. You'll see what I mean in the code. So let's begin coding. So just unsyncing here. Let's just go straight to a solve function. I'd like to keep my code in a solve function just because it's a bit cleaner. Of course, if you're trying to go as fast as possible, it should probably not if you don't need to. Because like if there are like multiple test cases, then the indentation can get a bit extreme. So it might be best just to restart with the solve. Anyways, so we're given 3 integers m and k. So int n m k, and then we can just see them. Okay, now we're also going to get given the string itself. So the way I'm going to store this, I'm going to just store it as a vector of string, not a vector of characters. That would be a bit annoying, but the string is a vector of characters, yeah. So let's just store that. So we'll just do signal. And because we don't really care about the m, we only care about the n because we're storing it as a vector. We only care about each row. It will just be size of n. So for each string x in signal, we can just c in x. So this is a really quick way to just do that whole for I and n, c in whatever, c in signal I. It's a quick way to do it. Anyway, so now we have that. We need to add the k multiplier. So consider a multiplier horizontally. Okay, so if we do it horizontally, for every character, there's going to be k lots of that character horizontally. So we're going to iterate through each row. Okay. So let's go. Okay, so we're gonna create okay. Now we're gonna have to iterate through each character of the string. So for int j equals 0, j is smaller than signal I dot size. There will be like a warning here, but it's just because it's not integer. And we can just increase j. Okay, so new string dot push back. Now this is going to be a really cool way on new string plus equals. So if you want to repeat a certain character X amount of times, you can use the string. Sorry, you can use the string function. So you just put in the amount of times, which is k, because that's how many times we're multiplying it by. Because k times the one character is always going to be k. And then the character you want, which is just signal I, j. Now that will get us the new string by row-wise. However, now we need to also output it column-wise. So if we just output it, we don't need to store it to a variable, nothing, because it'll be in order. So I'll use j again. J is smaller than k plus. Then we can just see out new string, line at the end, and return. I'm not going to do the file input output yet. I just want to make sure this works. So boom, there. Oh, hold up. Did we? Oh, sorry, I forgot that. Yeah, it's just a warning. Don't worry about that. You can just put into the, and life is easy. Yeah. As you can see, the inputs match. Of course, you can just write a diff file to see, but I think it looks good to me. So what we're gonna do now, we're just gonna add the file inputs in. So it's cow signal.in, read stdin. Std out. Yes, okay, so now we saved that. We can just go upload. Hopefully it'll be correct. Yep. Yep, okay. There you go, guys. That's how you solve it. The takeaways from this, just look, this is a very observation-based pattern, observation-based question, so it's quite an obvious to answer, but it's really good for new programmers. So you can obviously see here that we're just increasing it, you know, for each character. There's k lots of that character now, and then the same thing for rows. Yeah. So the way we approached it, we just did each row and then multiplied it by the column. It works. And yeah, I hope you enjoyed the video, guys. Stay tuned for the next one.